What are our two rules for writing domain and range for discrete problems?
Is one of the rules no repeats?
No repeats. Beautiful. What's the other rule?
Vertical line test.
That's something else. I could guess what you're saying, Andre, but I don't really know. What do you mean by that, Andre? Least to greatest. Oh, duh. Oh, she just told me duh in the chat. Yes. Least to greatest and no repeats. All right, so as we look at those x values, right? Domain's all about our x's. Well, they're already in order and they're not repeating, so that's easy peasy. Make sure you do a curly brace. If you're typing this out, the curly brace is right there above the enter button. It's the shift of the bracket. So you could type in curly brace. Right. Range. And none of those were repeated, but they're not in order this time. -9, -5, -2, 3. So those are the x's we could plug in. These would be the y's that can come out. Right. Is this a function or not? And why or why not?
Could you use the vertical line test on this?
No. Why not? Why can't we use a vertical line test?
Well, it's not on a graph, but
there you go.
If
you could, yep, you'd be wasting a lot of time doing that though. There's a lot faster way to know.
Yeah.
But yeah, it would work. Yeah, just take a long time. Yeah. All right, so June's saying all the x's have different y's. That's not actually why it's yes, June.
None of the x's same number, so they wouldn't cross. Kind of. It's like, like when you're doing the vertical line test and you have the 2 points on number 3 that are right on top of each other. That wouldn't work.
Yeah. So what's going on there, right? That those 2 points have the same x value, but different y values. So the same x can't have 2 different y's. I don't know if that's what you were trying to say, June. The same x can't have 2 different y's or multiple y's associated with it. So that's really the part that needs to be included, is that each input, each x can only have one y, one output associated with it. Or the same x can't have 2 different y's or multiple different y's. Okay, so yes. So this is kind of really this is the straight up technical definition of this. Each input has only one output. All right, so each x has only one y. And so just that idea that if it said also -1, 3, if that was another point in our list, then all of a sudden this is not a function, because that one input has 2 different outputs. It's still a graphable thing, still a relation, it's just not a function. So that's all it means. There's nothing bad about that happening. It's just not a function. So, okay. I'll leave you guys to do 2. Jared's already answered part of 3 for us. He told us that was not, and he mentioned the vertical line test. And you could just say, fails the. Again, I told you guys you could just abbreviate that, the vertical line test. And, what he was seeing there was that, again, I already pointed it out, but you draw a vertical line here and it hits 2 different y values. That's no good. Oops, what am I doing with myself here? The roof, your roof. in a first and third hour, we were practicing our school appropriate cursing because the iPad wasn't working. You guys got any school appropriate cursing?
Just curse.
Huh? You just don't like curse, just straight up.
Well, and then when it gets bad enough.
What do you mean for this, Audrey? Are you talking about 3 or are you talking about 4? No. Remember 3 is discrete, so you need to write it like number 1. So it's going to be the curly braces. Only when they're continuous do you do the interval. Think you guys got 3 as far as the main range? Or do we need to go over that? Okay. So 4 is continuous, so it's different, right? So we got to think about that. So we need to be using interval notation. Right? It's just the 2 numbers, comma, brackets, or parentheses. Okay. I've seen some people like trying to draw with the doc hub, and I can't tell the difference between a bracket and parentheses. It's unless you're an amazing doc hub drawer. It needs to be really clear to me what you're trying to do. That's a bracket, or that's a parenthesis, or it's not some like thing like this. Like I don't know what that is. So I would suggest just type it out instead if I was you guys. It's clear. Remember domain, our x values, leftist to rightist. What's our leftist value? It's like -2. What's our rightist value? 5. So from -2 to 5, we can pick brackets or we pick parentheses based off if it's hitting the number or not. And remember, unless it tells us it's not, we have to assume that it is. So we're hitting -2, we're hitting 5. So it's brackets on those. Okay. Leftist to rightist, and then the range is lowest to highest, right? You need to, I like that alliterative way of saying that. So we always remember to start on the low side, just like the rule for the lists we were just writing. It's low to high. Okay, it's the same way here. Okay, and so what's my lowest value? Looks like -2 again. What's my highest value? 4. We're hitting those points, so they get brackets. Remember what this means, okay? It's every number between -2 and 5, including -2 and 5. And this is every number that's between -2 and 4, okay? What can I plug in? What numbers are allowed to plug in? Only these numbers. Every number between -2 and 5. What numbers could possibly...
Where'd you get that 5 from?
All right.
Oh, is that 5 to the right?
Yep. Leftist,
Okay.
leftist to rightist. So only numbers between -2 and 5 can be plugged in. Only numbers between -2 and 4 would come out. And we would never get 7 as an answer. We'd never get -12 as an answer. We can't plug in -12. We can't plug in 7. That math just doesn't work for that problem. Okay?
Yeah.
And is this a function? Nope. Okay. Vertical line test again. Okay. Fails the vertical line test. Okay. Anything you guys want to clear up on 1, 3, 4 before we move on?
Just zoom out real quick.
I don't know what else you'd want to see. That's all we've done. Okay. 5, 6, 7, 8 down here. We're going to be using these functions. I'm going to let you guys do 5 and 6 because it's just straight up plugging in, that number into that number into that, get an answer. I want to do the compositions with you guys. Remember, when we read f of g of x here, what we're supposed to be thinking about is that g, it's inside of f. Okay, so we need to be taking g and putting it inside of f in place of the x. And the number one most common mistake people they make is they just shove it next to the x. Remember, it'd be really awkward if the substitute teacher was here and the teacher were here. Okay? When you substitute, that x needs to go away, not hang around. So when I'm looking at f, which is -5 times something, I'm going to put a hole where that something was, -14. And what's my something now? It's whatever g is. Well, g is 2x plus 5. Okay? So notice how we have an x here. There's still an x in the problem. Over here we have a number. There won't be any x's in our problem. Okay? And there is not an x here. That x was replaced by this. Okay? This is the setup. This is the part people usually mess up. The rest of it's cakewalk. Do you guys have questions here on the setup of this? It's a lot faster if you guys say no or yes instead of making me just wait.
Yes.
Yes? Do you have questions?
You said say no or yes, so I said yes.
Do you have questions, Brian? Or are you just being a pain?
No, I think we're good.
Okay. First Audrey sassed me, now Brian sassed me. Ugh. That's what is going, I guess. How about this? All right, so -5 times 2x is -10x. -5 times 5 is -25. -14, like terms to combine. So -10x, and then that would give us -39. Okay? And so then make sure you put your answer back with the notation, please. Should look like that. Okay? We put a function inside of a function. We got a new function. All right, there's an x here. There better be an x here. There's a number here. We better just have a number answer. Okay? Same kind of starting process here with 8. Right? We're looking at that inside function. We're going to take whatever we get. We're going to plug it into that outside function. Well, on this inside one, I have something to do now. And the last time I didn't because it said plug x in. I don't need to plug x in. X is already in there. Okay? But here it says plug 2 in. I need to do that because I don't know what f of 2 is. I know what f of x is. It says me what x of x is. It's right there. Or I don't need to figure out what g of x is. It tells me what g of x is. But I don't know what f of 2 is. It doesn't tell me that. But I could find it. So f of 2 would be -5 times 2 minus 14, which of course is -10 minus 14, which is -24. What do we do with that answer? Take whatever we got here and we plug it into G. Okay, so I'm taking that -24, I'm going to drop it into G. See if my memory serves. It's 2 times. I was with the 2. I can't remember. 5, 10. I don't even remember. You guys are no help. 5. Yeah. Okay, let's do the math. -2 times 24, or 2 times -24 is -48, plus 5, which is -43. All right, so we did all the math we're supposed to. So g of f of 2 is -43. If we were going to try to graph that picture, I would throw numbers at it, let it spit wise back at me and plot those points, right? I'd plot the point to -4, 3, 3. Then I'd plug in the next number, see what it gives me so I can plot that point. I'd plug in the next number, see what it gives me so I can plot that point. That's graphing, guys. Just throw x's at it. They give you answers and start plotting points. Okay? If you're ever confused about how to make a graph, just start throwing x's at it. Okay? 9, 10, domain and range again. Is it discrete or continuous? Right, we've already kind of talked about that. Again, you really should answer the discrete or continuous part first, because knowing whether it's discrete or continuous will tell you how to write the domain and the range. Okay. So looking at 9 and saying, okay, that one's discrete, I'm going to make those little curly braces ones. Looking at 10, saying, okay, that's continuous. I better use interval notation here. Okay, so you got to make that. Even though it's the third question, you need to answer this one first, at least mentally, if not physically. Okay, so you can understand how to do the first two. So why is this continuous? Why was I so certain that this was a continuous graph?
The arrows.
No, Brian.
It's a solid line, not scrambled dots.
Okay, so they don't. You guys are all over the place. Yes, a solid line. I like that. Has nothing to do with being scrambled dots. The dots can be in a nice pattern. Nice. The dots can be all lined up. That's fine. That's still discrete. It's solid. It's connected. Remember the word Jared used earlier. They're connected. Okay. Brian, you're hitting on the most confused thing about if something's continuous or not. Okay. You got to make sure you get your mind straight here. Continuous does not mean arrows. Continuous does not mean goes on. It means connected. Okay. Did that circle that we looked at earlier go on? Did it have arrows? No, but it was still continuous. Okay, because it was a solid line, like Mason said. Okay. All right, or they were all connected, like Jared said. So when we're thinking about domain, what two words should be popping in our head? You're dancing, yes. What two words should be popping in our head?
Your leftist to rightist.
Leftist to rightist. So what's our leftist point here?
Infinity.
Yep. It goes left forever. What's our rightist point? Positive infinity. So from negative infinity to positive infinity. Infinities always get parentheses because we can't reach infinity. We can't hit infinity. Okay. I don't care that this arrow is going down. I care that it's going left. I don't care that it's going down. I care that it's going right. Because that's what domain is about, left to right, x values. Okay. What's my range? What are my two words for range?
Highest and lowest, or uppest, or
Say it backwards, Jared. Lowest to highest.
lowest to highest.
Okay. Our lowest point. And it points down forever. Our highest point. 2. It's hitting 2, so it gets a bracket. Can't hit infinity. No parenthesis. Okay. What does that mean? It means we can plug in any x value we want into it and it'll give us an answer. What answers will we get? Only numbers that are 2 and less. We'll never get 5 as an answer to this problem. We'll never get 12 as an answer to this problem. We can get negative 12, we can get negative 5. We can't get positive 5 or positive 12. Okay? Or positive 2.1. And it stops right at 2. Okay. Anything on the front you guys want to talk about? Before we move off to the back. Brian, what's continuous mean?
Brian,
What's continuous mean?
all the things are connected.
Okay, good. Okay. 11, 12 here, a lot of questions, but domain, range, x-intercepts, y-intercepts, those should be easy peasy for you guys, okay? I know the increasing, decreasing is more difficult, so we can talk about that, okay? But we just did domain and range, leftist to rightist, So we're seeing that arrow. This is continuous, right? So we're going to do, interval notation. So negative infinity, and it's stopping at 5, except for, right, open circle means not touching, right? There's our very specifically saying it doesn't reach 5. It gets right up next to it. It hits 4.9999999999999, right? But we can't write that down, so we have a symbol for that. Right? That's what this means. The number right next to 5, but not at 5. Okay. Leftist, rightist, lowest, highest. -4 is our lowest value. It goes up forever. Even though this one stops, this one goes up forever. So it keeps going, right? It keeps covering all our bases. It hits that -4 because it doesn't tell us otherwise. And then do that. Okay. X-intercepts, y-intercepts. I would like you guys to write those as ordered pairs. Okay, so my first x-intercept there is at 0, 0. And then you do an and symbol or a comma. Okay, the second one's at 4, 0. Okay, and this is a good time to talk about this, right? How do I know that this is not an interval? Right? That has parentheses. This has parentheses. How do I know they don't mean the same thing or not talking about the same thing? Because it's context. X-intercepts aren't chunks of something. X-intercepts are single points. They're a point where the graph is hitting the x-axis. So this has to be referring to a point. Domain is either a bunch of x values or an interval of x values. Okay? And if it's just single points that could be, not intervals, then we always use curly braces so that it wouldn't get confused. If it's ever parentheses here, it's always talking about an interval. So the context tells us that this language here has to be an interval, not a point. Okay? The context here says that this has to be a point, not an interval. The other one doesn't make sense for it. Okay? Our y-intercept is also 0, 0. Just coincidence. Okay? And then the increasing, decreasing, positive, negative. Okay? It's real tricky because the idea that we're looking up and down, but we're talking left to right. This question is asking what x values make the y values increase? What x values make the y values decrease? Your answer has to be about x and its effect on y. Okay? What I asked you guys to do with this was put your pen on the paper or on your computer screen and drag it along the path as we go from left to right. Okay? As I try to go from the left to the right, I'm forced to decrease during this interval. This chunk of the graph is decreasing. This piece, this part, okay, of the graph is decreasing. But this part over here is increasing. Okay? It's not right for me to do that with my hand, but okay. So when I want to talk about what's decreasing, I would say these x values, I'm putting off an arrow because it goes to the left forever, but everything from 2 to the left causes the x value or the y values to drop as I come from that left side. They're coming down, 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 down. Yeah. So my decreasing interval is from negative infinity to 2. That's where things are dropping. It stops dropping at 2. Did I ask you how low does it get? No. So I don't care. I'm not going to talk about the -4. That's the question. That's the answer to that question. I asked you, when is it happening? And that's an x question. Okay? It stops dropping at 2. Okay? We never include that. We never include the turning point. Right? It's turning at 2. We never include that. So that always gets parenthesis. And then, of course, infinity is always going to parenthesis. Well, where's it increasing? Starts increasing right here. And as we move to the right, it keeps increasing until the graph stops. The graph stops just short of 5. So in this window, the graph is increasing. Well, it started at 2, and it stopped at 5. we never include the turning point. So that 2 gets parenthesis. And then the 5 has an open circle, so it can't get included because it doesn't actually reach 5. It stops just short of 5. Okay. I'd like you guys to be physical with your paper or your computer screen when you're doing this. Okay, put your finger on that and drag it and say, what do I have to do, right? Until you get good at it. Okay, what do I have to do here? As I follow that path, what else am I doing? I'm also going up. Okay, that's increasing. Because people look at that arrow and go, oh, that's increasing. That's not the right way to think about it. As I move from the left to the right, I'm dropping here. Then I'm going up. Okay, put your finger on it and it makes it so much easier. Read it like a book, left to right. Okay. And then we go to positive, negative. Again, positive means above x-axis, negative means below the x-axis. Now we're about out of time, where we are out of time. That's an up and down question or thought, but we have to talk left to right. What x values are making it go above the x-axis? What x values are making it go below the x-axis? So where is it above the x-axis? Where is it below the x-axis? What interval? Okay. So everything from here, that way, is above. All right, well, how do we write that? Always from left to right, from negative infinity to 0. Parenthesis, parenthesis. We do not include the 0 because it's not positive, it's 0. Where else? Starts at 4, and it's above the x-axis this whole time, between 4 and 5. Parenthesis, parenthesis. We don't include those points. Okay, no brackets, no brackets, okay? Where is it negative? Last thing, right? Everything in this space is negative. What x values are those? It's from 0 to 4. All of those x values up here, okay, from 0 to 4 are negative y values. If I plugged in 2, I would get a negative y answer. If I plugged in 3, I would get a negative y answer. Yeah, that's what it's saying. Okay. I want you guys to do 12. Try 13, 14. We've just been doing that here recently. Okay. The last 2 days, 3 days, we've been talking about that over and over again. Same thing with 15. Okay. These last 3 questions should be really fresh in your head. So it should be easier. Okay. But try them. I'll have the key up. If you're not getting what the key says, then you need to be asking questions. Do not just write down what the key says and call it good. Okay. You guys know what you need to do? CTM.
See you, Mr. Baker.
Bye, Drip.